All right, so all the way back in 2021, Elon dismissed a battery technology that could charge up to 60 times faster simply because its energy density wasn't sufficient for use in Tesla EVs. However, he might be regretting that decision now, as it could potentially offer a 400-mile range with a lifespan 3 times longer than the lithium-ion batteries Tesla currently uses. But what's even more astonishing is that it's been upgraded to charge 70 times faster, allowing you to fully charge a Model Y in 8 minutes. Elon might regret it even more when he realizes it costs a fraction of 4680 cells. Yes, the graphene aluminum-ion battery is the buzzworthy tech with a host of impressive advantages. Will Elon reconsider? Let's find out now. That's absolutely right. Every battery's got a certain number of charge and discharge cycles. A complete cycle is from the point the battery's fully charged to when it's fully discharged and recharged again. After a specific number of cycles, the battery capacity begins to decline. High temps can accelerate this degradation process. When a battery overheats, the chemical reactions inside become unstable, leading to decreased performance and lifespan. Conversely, extreme low temperatures can also impact the battery's ability to charge and discharge effectively. To address this drawback, Graphene Manufacturing Group has developed a battery technology that everybody's been talking about due to its impressive and almost unbelievable performance: the Graphene Aluminum-Ion Battery. As soon as we learned about this battery, we immediately found ourselves wondering why we hadn't heard about it sooner. The graphene aluminum-ion battery charges extremely quickly without increasing in temperature. What does this mean? Typically, about 16% of the weight of a lithium-ion battery is dedicated to cooling. Additionally, you need heat sinks or other cooling components which take up extra space and increase the overall size of the battery pack. Therefore, if we adopt graphene aluminum-ion battery technology on a larger scale, we believe complex cooling systems may no longer be necessary for this type of battery. You might need a new fans in the battery pack, but you probably wouldn't need liquid cooling systems or anything like that. And this is exciting because it would result in a much simpler and lighter battery pack. The weight of the battery is pretty crucial for EVs, right? 1. What is graphene aluminum-ion battery? Right from the get-go, when we heard the name of the battery, we have to affirm that it's got great potential with 2 main components: graphene and aluminum. Now, if you're interested in battery news, you'll know that graphene, a form of carbon with a 2D crystal structure and with outstanding properties such as high conductivity, great durability, and lightweight, helps increase the charging and discharging speed of the battery. This means that batteries using graphene can charge much faster than traditional batteries. Meanwhile, aluminum, a metal with large reserves in the world, as we know it is the 3rd most abundant metal in the Earth's crust, so it's many times cheaper and has a supply 1,000 times more abundant than lithium. More specifically, it can be recycled and is more environmentally friendly than the components in traditional lithium-ion, such as cobalt and nickel. The ratio of graphene and aluminum is 50-50, and the advantages of combining these 2 types of materials allow Graphene Manufacturing Group to develop graphene aluminum-ion battery. And they're confident that they are the world's pioneer in this technology. To put it simply, the cathode in these batteries is a metal foil coated with graphene, while the anode's just a simple aluminum foil. The battery operates on the movement of aluminum ions between the electrodes, similar to other types of batteries. Manufacturer states that they don't use lithium ions for charging. Instead, they use aluminum ions because utilizing aluminum ions represents a breakthrough in battery technology, often seen as the ultimate goal for any battery technology outcome. In the graphene aluminum-ion battery, aluminum chloride atoms serve as the electrolyte. GMG also mentions that aluminum ions will move from the anode to the cathode, rather than in the opposite direction as seen in lithium-ion batteries. At this point, we think you got a pretty good understanding of this battery. It's pretty straightforward, right? 2. Energy density of graphene aluminum-ion battery. To be honest, for any battery tech, the energy density of that battery is always the most critical factor in determining whether it'll be used in EVs, accounting for about 80% of that decision. This means that for the graphene aluminum-ion battery to be adopted by Elon and Tesla in their EVs, they need to have an energy density that's better than, or at least equal to, the batteries Tesla's currently using. Right now, the LFP has the current lowest energy density among those used by Tesla, around 165 watt-hours a kilo, while the highest is 272 watt-hours a kilo for the 4680s in the Cybertruck. This indicates that the graphene aluminum-ion battery must genuinely have an energy density within that range, and as far as we know, it's achieving higher numbers than any current batteries, but only by a small margin, at about 300 watt-hours a kg. According to Greg Nickel, the founder and CEO of GMG, at the beginning of 2021, the graphene aluminum-ion battery cells had fairly limited performance with an energy density of only 150 watt-hours a kilo, much lower than the 250 to 300 watt-hours typically seen in lithium ions. At that time, Elon remarked that this was an impressive battery, but GMG needed to improve. That means that while Elon was impressed with the graphene aluminum, he was looking for higher energy density. However, by 2022, GMG had improved everything 6 times over. They worked hard to handle the first issue, how much charge can be stored in this per weight, and their efforts paid off, resulting in an increase in energy density, which hit 300 watt-hours a kilo. And so far, we haven't gotten any updated figures on the current energy density of the graphene aluminum, as GMG previously disclosed that it would exceed 300 watt-hours a kilo. They may announce this at the end of the year when they start mass commercialization of this battery. Although the density is slightly higher than the 4680, it's clear these cells can provide better range to some extent. A range of up to 400 miles is not an exaggeration, and you should remember that it's much lighter than the 4680 because the battery pack will reduce the cooling components. However, what makes us see it as more suitable for Tesla is that it's actually very cost-effective. GMG CEOs confirm this, and you might not know that Elon always prioritizes low cost as the top factor before considering performance. 3. Graphene Aluminium-Ion Battery cost. Many people dislike EVs because after a long period of use, like 6 to 7 years, the battery pack becomes quite weak, while the cost of replacing it can be tens of thousands of dollars. Tesla's EVs have a battery lifespan of up to 10 years, with 60% of Tesla EVs using LFPs, while the rest use 2170 and 4680 batteries. Tesla prioritizes LFP batteries because they're inexpensive. They cost about $75 a kilowatt hour. However, in exchange, LFPs have a relatively low performance, while the other types of batteries just cost more. In battery cells, the anode accounts for over half of the total battery cost. In a typical lithium-ion battery, the anode's made up of lithium and other metals like cobalt, nickel, and manganese. Comparing metal prices, lithium costs $13,000 a ton, while cobalt, nickel, and manganese are currently priced at $7,124 and $2,500 per ton, respectively. Aluminum is much cheaper than those metals, costing around $2,078 a ton. As for graphene, it's quite challenging to find pricing data for its production as the material's cost fluctuates, but we found it typically costs around $100 a gram. However, this cost is decreasing, and it's unclear how much GMG is spending to produce their specific mixture. Nonetheless, considering that aluminum's 10 times cheaper than the expensive materials found in lithium batteries, it confirms that the price of the graphene aluminum-ion battery cells will also be much more accessible. GMG doesn't disclose details because, as you know, very few battery manufacturers reveal specific costs for each kilowatt hour, as it's quite sensitive info. We only really know when Tesla buys these types of batteries and uses them for their EVs. In some ways, Tesla's electric vehicles will definitely be cheaper if they operate using these battery cells. As mentioned before, the charging times being over 70 times faster is the biggest breakthrough that gives GMG confidence in this type of battery. The company's CEO even stated that a mobile phone could be charged in just a few minutes with these batteries. What makes this battery charge up to 70 times faster? Although it sounds confusing, this is what the manufacturer explains about how graphene aluminum-ion batteries can charge dozens of times faster than other types of batteries available on the market. Specifically, in addition to using good conductive materials, GMG has employed plasma techniques to produce graphene layers, which are so closely layered that the aluminum chloride, about 5.5 nanometers in size atom that they're using, can't fit between the carbon atoms, about 0.3 nanometers in between. They essentially drill tiny holes in the carbon layers, which happens during manufacturing, so that aluminum chloride atoms can sit in them. In addition, compared to lithium ions, aluminum ions have better energy storage capacity and interact strongly with graphene, improving charging speed without reducing battery performance or durability. All these structures and tightly packed aluminum atoms make graphene aluminum-ion batteries charge up to 70 times faster than lithium ions, according to the company. Normally, Tesla batteries can go from 30 to 40 minutes to fully charge, but with a 70 times faster charging battery, it only takes about 10 minutes, actually 7 to 8 minutes. It sounds unbelievable, but it's true. 70 times is an incredibly fast charge. Currently, the fastest charging batteries are from CATL, the world's leading battery manufacturer, have also allowed their Shenzhen batteries to fully charge in 10 minutes. Not only does this method allow rechargeable batteries to withstand high temps without damaging their lifespan during charging, but it also extends the battery life to 3 times longer than usual. GMG has its own ways to inhibit these thermal reactions. 5. How does graphene aluminum-ion battery triple its lifespan? According to the manufacturer, the increase in battery life by 3 times has the graphene in the battery being used in a coating that GMG has launched and selling. The coating uses quantum thermodynamics to shift heat from the normal way sheet heat is moved, which is in conductivity, to a light wave called foam, and that's either traveling at the speed of light or at the speed of sound, depending on what axis it's on. In this way, GMG's graphene can transfer heat faster than conventional methods, which helps solve one of the biggest challenges for batteries: managing temperature during fast charging. Another reason is that graphene aluminum-ion battery has a very low internal resistance, which means it operates more efficiently and generates less heat. When you combine these two factors, where heat's transferred to the outside because graphene acts as a heat transfer medium, and the low internal resistance, this is why graphene aluminum-ion batteries only increase in temperature very little during charging and discharging. But that's not all. For graphene aluminum-ion batteries, it's able to absorb and regulate heat from the discharge and charge areas where the temperature increase usually happens. The manufacturer also transfers heat to the outside thanks to graphene's ability in quantum thermodynamics. In the test, the temperature of a conventional battery cell was 61 degrees Celsius at a discharge of 4.8 degrees Celsius, while the graphene aluminum-ion cell was only 30 degrees Celsius at a discharge of 20 degrees Celsius. This suggests that there's probably no need for any complex cooling system. The manufacturer believes that just a few fans are needed in the battery pack, but there's probably no need for an actual liquid cooling system or other complex systems. Of course, GMG has tested many times to get the most satisfactory results, and all the tests with this proprietary method show that the graphene aluminum-ion battery can be charged quickly without the need for a complex cooling system, a great advantage for the application of this technology in practice. Despite the huge effort put into achieving impressive performance figures for its batteries, it's clear GMG has not forgotten to put environmental criteria first. According to CEO Craig Nickel, the company has tried to minimize emissions in the production of its graphene as much as possible. Obviously, refining aluminum from bauxite ore will also create a lot of emissions, but this is a material that's already 90% recycled, and recycling it is much more efficient than processing it from virgin ore, and it's also more sustainable than mining lithium and cobalt. GMG has also considered a partnership with Rio Tinto, the world's second-largest metals mining group. GMG wants to take their low-emission or zero-emission aluminum and combine it. From these production strategies, the battery manufacturer will have graphene aluminum-ion battery cells that are produced with very low emissions and graphene aluminum-ion batteries that will have thousands of cycles of use, and we can eventually recycle them. This is the advantage that we value very much about this kind of battery. When it comes to this, all the issues and advantages of the battery seem to have been addressed. And surely you're wondering if it can truly provide an energy density of 300 watt-hours a kilo, charging more than 70 times faster, triple its lifespan, and is incredibly cheap to produce. Why is it not yet available on the market yet? So, what has held GMG back from launching the graphene aluminum-ion battery until now? The situation reminds us of several promising types of batteries that, despite being frequently mentioned around the world, have not yet been released, such as solid-state batteries and salt batteries. Clearly, there are some barriers preventing the graphene aluminum-ion battery from appearing in EVs. In discussing this, GMG openly acknowledged three main reasons for the delays in developing the aluminum-ion graphene battery. First, as we mentioned earlier, the energy density of this battery is only about a third of traditional lithium batteries, at 150 watt-hours. This makes it unable to generate the necessary appeal to capture market attention, and even when Elon dismissed it for this reason, over the years, the research team has tirelessly worked to significantly improve performance, even achieving a six-fold increase compared to before. And therefore, in order to reach over 300 watt-hours a kilogram, GMG has been facing a challenging journey towards perfection. Now, the second reason for the delays in the graphene aluminum-ion batteries development is the considerable challenge of sourcing lightweight and thin materials for testing and optimization. Just having access to materials does not guarantee success. Managing and combining them to create a superior product is a journey fraught with difficulties. Finally, the issue of electrolyte corrosion has previously been a significant barrier threatening the battery's lifespan. However, through creativity and perseverance, GMG's scientists have overcome this challenge. Thus, despite the initial obstacles, the manufacturer has addressed each issue and made progress. As a result, it can be made in large quantities and is set to supply battery cells to the EV market by the end of the year. From an economic perspective, the demand for graphene aluminum batteries is likely to surpass any other battery tech in the future, primarily as a potential alternative to lithium batteries in the EV sector. The first graphene battery cells were made in June of 2022, and GMG also plans to establish its first commercial facility for the production of graphene aluminum-ion batteries, which will be used to manufacture coin cell batteries. With standout advantages such as charging more than 70 times faster, a lifespan 3 times longer, and lower production costs compared to Tesla's current lithium ions, graphene aluminum batteries present a compelling option. Although Elon previously dismissed this technology in 2021 due to its inadequate energy density, the improvements of up to 300 watt-hours a kilo, comparable to or even exceeding Tesla's existing batteries, make this choice a formidable contender down the road. Graphene aluminum batteries could indeed simplify cooling system complexities and reduce costs. This battery technology has great potential to transform the EV market, especially as the demand for green energy and cost-effective production becomes increasingly urgent. However, for widespread acceptance and use in Tesla vehicles, GMG still needs to refine the technology further and overcome challenges in mass production while proving its superior performance in real-world conditions. Predictably, if GMG can fulfill its commitment to commercialize this technology by year's end with the announced performance and cost, Tesla may have to reconsider and potentially collaborate or explore integrating this battery tech into its vehicle lineup in the future, especially since Tesla's priority remains on cutting production costs and increasing efficiency of their batteries. So, would you be ready to buy a Tesla EV equipped with graphene aluminum-ion batteries that charge more than 70 times faster and last 3 times longer? We certainly would buy one if Tesla uses this type of battery in their electric vehicles. And thanks for watching our video. If you found the content helpful and want to learn more about and want to explore more exciting information about Tesla's EVs, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss out on our latest videos. We really appreciate you watching this video and supporting the channel and hope to see you back here soon. Until then, take care and God bless. Bye.